My name is Megh Bhatt, and I am first year BTech student at IIIT ICT. And today I am going to present about nuclear power plant under the guidance of our course instructor, Dr. Jignesh Patel. The things which we are going to talk about moving forward in this presentation, which consists of flowchart of atomic energy commission in India, safety features, site capacity, uranium, fusion reaction of uranium, working at lab site, etc. etc. That shows the major atomic energy commissions in India, which consists of GIE, BARC, BRIT, USIL, NFC, HWB, and NPCIL, and REPS. Rest is most famous among all of this. So next slide, we are going to see how it progressed over the years. Slide shows REP difference units, its year, and its capacity. As you can see, REP Unit 1 was built in 1972 and its capacity is 100 megawatt. REPS Unit 2 was built in 1980 and its capacity is 200 megawatt. Now if I am going to read all of this, the video will be very long. So I think next, if you want to read, you can read it also. How nuclear power plant generates energy. So the phenomena behind it is it is called nuclear fusion. In this process, heavy nuclei divides into two nuclei to become more stable, and in this process, it releases energy and neutrons. And these neutrons excites another heavy particles, and the process continues until we stop it. So this way, we can create energy, and we can use energy in whatever way we want. Which is used majorly in nuclear fusion process is uranium. So let's know some facts about uranium. Uranium is a slightly radioactive metal that occurs throughout the Earth's crust. It is present in most rocks, soils as well as in many rivers and seawater. Although uranium is about 100 times more common than silver, uranium-235 is relatively rare. This is the nuclear fuel cycle by which we can generate energy. So first, uranium ore is mined. The uranium ore is milled into yellow cake. The yellow cake is turned into UO2 first and then converted to gas UF6. Gas is then enriched to increase the amount of U35. As you know, U35 is heavy stable material, so it generates energy very much. Then enriched UF6 converted back to UO2 and made into ceramic fuel pellets. These pellets are poured into fuel rods and used to make electricity. Used fuel is stored in the power plant site and in the future used for different projects and are stored in an underground storage. Understand about the term fuel fabrication. The fuel used in PHBR type reactor is sintered natural aluminum dioxide in the form of small pellets. These pellets are kept in the zinc alloy tubes and are 24 per tube. These tubes are known as pencil and 29 pencils make complete fuel bundle. The pencils are held between end plates and the zinc alloy provides spacing between the tubes. And zinc alloy pads provide bearing action and this help of mixing coolant flow with other channels between the elements creates fuel fabrication. The pictures of fuel bundle so you can get idea how it looks in real life. See, what are the components of nuclear power plant? It consists of calandria, control rods, fueling machine, heat exchanger, PHT pump, moderator pump, boiler, reactor building, coolant channel, fuel bundles, coolant tower, and turbine. What basically is a nuclear reactor? It is simply a apparatus of which the end result is heat, and this heat is further used to produce electricity. Understand what is pressurized heavy water reactor? The pressurized heavy water reactor concept allows the use of natural uranium as a fuel without the need of enrichment. As we seen before, in nuclear reactor we can only use U235 uranium, but in this we can use the natural uranium as it is. However, it needs the installation of a heavy water due to production capabilities. If you don't know, heavy water is the water molecule, but in that hydrogen contains two nuclei. Most of the world's nuclear reactors are heavy water based. So because in heavy water based nuclears are cheap, because in that we can use natural uranium only, which is not as much rare. Now let's one by one understand what are main components of nuclear power plant. The first part is reactor core. It consists of fuel elements, control rods, coolant, moderator, and pressure vessels. Cores generally have shapes of right circular cylinders with diameter ranging from 0.5 to 15 meters. Fuel rod is made up of aluminum rods clad in thin sheet of stainless steel, zirconium, or aluminum. Second are control rods. It is made up of heavy mass elements such as boron and cadmium. Cobalt, it simply absorbs the neutrons so that it can either maintain or stop a reaction in case the reaction goes out of control. In traps, cobalt is used as a control rods. The used cobalt is then processed and enriched. Then enriched cobalt is then used for different purposes such as cobalt therapy, etc. Its uses for starting the reactor, for maintaining at that level, for shutting down the reactor at normal or at needed level. Third major part of nuclear power plant is moderator. Its function is to slow down the neutron from high velocity and hence high energy level which they have on beginning released from fusion process so that the probability of neutron to hit the fuel rod increases. Types of moderator: water H2O, heavy water, graphite, beryllium. Main properties: high slowing down power, chemical and radiation power, high tendency. The part is coolant. Its function is used to remove the intense heat from the produced in the reactor, and that heat can be transferred into water in separate vessel which is converted into steam and runs the turbine. Most commonly used coolant is CO2. Characteristics: low melting point, high boiling point, low viscosity, low toxicity, non-corrosiveness. This diagram here shows how power is generated in nuclear power plant. You can look through it and you will understand how it generates. Now let's see some of the safety features used by nuclear power plants organizers. The safety instructions are: awareness of the risk at the site, move towards the nearest safety location at the time of hazard, use safety helmets, cover the nose with wet cloth. Reactor safety measures are: emergency reactor shutdown, high pressure safety injection, double layer concrete reactor building that does not allow radiation to exit the reactor building at the time of the hazard. This is a picture of how waste is managed in nuclear power plants. Let's see how used cobalt is used. It is a unit of Board of Radiation Isotope Technology which uses the spent fuel and control rods to generate cobalt-62 for various functions such as cancer treatment and eradication of food supplements. In other words, it helps in nuclear waste management. It deals with the low-level radioactivity waste. Thank you everyone for the time. That was my part, and I would also like to thank our course instructor, Dr. Jignesh sir, for providing us the opportunity to make this presentation.